These heat waves are no longer just fun, they're quite frightening.
Europe experiences a month few will forget.
Schools are closing, train lines are buckling.
And beneath the waves, the ocean is sending warning signs of its own. Coming up, we explore one of the Earth's hidden climate engines, where scientists are discovering the unexpected.
Do you see that happening again, possibly in 2027?
It's entirely possible.
Our trajectory is, not the most positive.
We'll also meet some of the smallest life forms on Earth with one of the biggest jobs. Just 2 degrees is on. Now. The ocean. It is the largest living system on our planet. Covering more than 70% of the Earth's surface, it connects every continent, shapes our climate, and makes life on Earth possible. It even helps us breathe. More than half of the oxygen we rely on comes from tiny marine plants drifting through the waters. And beneath the waves is a world unlike any other. From microscopic plankton to the largest whale. From colorful coral reefs to the deepest, darkest ocean trenches, millions of species call it home, and many have yet to be discovered. It is one of the most extraordinary places on Earth.
But that world is changing. Marine life is being pushed beyond its limits. Plastic and pollution are reaching even the deepest parts of the sea. Overfishing is emptying once abundant waters. The ocean is now hotter than at any point ever recorded for this time of year. And as we continue pumping greenhouse gases into the atmosphere, the ocean is becoming warmer, more acidic, and less able to protect both nature and us.
With marine heat waves, they change the physics, the chemistry, and the biology of the ocean. So from a physics perspective, we get more evapotranspiration, which enables more energy available for storms. So storms can be more intense and drop more rainfall. We also see less of a transition between daytime and nighttime temperatures. So when you have a very hot coastal ocean, you're not getting that cool sea breeze coming in at night to provide that relief from the temperatures during the day. So warm ocean temperatures amplify the heat waves. And then it changes the chemistry. So Oceans that are warmer carry less oxygen, they're more acidic, so it's harder for life to grow. That leads to things like coral bleaching or mass fish mortality. And then it also changes the biology. So we get things like harmful algal blooms, organisms that we don't particularly like jellyfish, are more comfortable in these conditions. We see more invasive species, and we see range shifts with fish moving offshore to other parts of the ocean where it's cooler and where they can find those prey species. So that brings potential challenges for people whose livelihoods depend on the ocean resources.
Samantha, does El Nino developing the Pacific mean more heat records will be broken in July and the rest of the year?
So El Nino is still developing. And when we look at the tropical Pacific Ocean, we can see that there are exceptional ocean temperatures there. And we know, looking at the dynamics of this particular event, that there is a connection between the ocean and the atmosphere. And the forecast at this point in time is that this event will peak sometime around November, December, so later this year. We also know from the seasonal forecast models that the anomaly or the amplitude of how exceptional this event, it looks extraordinary. It looks in the range of 3 to 3.5 degrees above average. And we also know from historical El Nino events that the biggest impact on global temperatures is actually the year after the event has reached its peak. So we are likely to continue to see exceptional temperatures throughout the summer in Europe, and more importantly, throughout the cooler parts of the year when we'll have more of an impact from this El Nino event.
You know, before the interview began, you were telling me how hot it was on this day and how difficult it is to cope with these temperatures. Does working in this field while feeling its impact personally make it easier to communicate the urgency, particularly to people who don't experience similar conditions?
Yeah, I think it's really interesting, particularly for a very international audience, because so in the United Kingdom and in large parts of Western Europe, there isn't the infrastructure for air conditioning. And our houses are ultimately designed to keep the heat in rather than keep it out. So generally speaking, the first few days of a heat wave are not too bad if you keep the curtains closed, you keep the windows closed during the day. You know, our house in particular, we can keep a 10-degree difference between the inside temperatures and the outside temperatures, but that gradually keeps up. And when it's not cooling down until midnight or something like that, it means we can't get that airflow into the house to cool it down, so that the house gradually accumulates these temperatures. Air conditioning is definitely part of the solution, but in addition to that, you know, we've had to create more climate resilience in our house. So we've put external blinds on our house that are reflecting the sun off the windows to reduce the heat coming directly in. And I think, you know, we are seeing this transition from climate change being a abstract concept that you read about in reports to disrupting our daily lives. You know, schools are closing, train lines are buckling. We've had heat health warnings where non-essential travel has been advised not to happen. We've had the emergency services show their record-breaking call-outs for heat impacts to the vulnerable. So we're really seeing Europe is not fit for purpose for the climate we're currently living in. So we do need to adapt as quickly as possible and really look at a range of different adaptation measures to ensure that we can you know, work with everyone's budgets and work with what people can do to their own home and their own infrastructure.
Thank you, Samantha. I hope you find ways to cope this summer. Well, a recently published study by researchers at King Abdullah University of Science and Technology in Saudi Arabia describes how marine heat waves aren't just a summer problem anymore. They're happening all year round. The findings suggest the ocean is no longer following the patterns scientists once expected.
Dr. Shannon Klein is the lead author of the study titled Year-Round Marine Heat Extremes Severely Impact Marine Life During the First Year at 1.5 degrees Celsius Warming.
Yeah, so when we talk about global warming, we measure this usually at the surface, the essentially the area in which we're inhabiting right now, just on land. And the surface of the ocean actually reacts quite quickly to air heating up at the surface. And so this was one of the major findings of the study, is that there was almost no lag at all between heat at the surface of the Earth and what happened to the surface of the ocean. And then, of course, once the heat is absorbed by the ocean, and then that heat can then penetrate downward into the deeper layers over several decades and even centuries.
Your study suggests the ocean is no longer behaving the way scientists often expected. So what changed?
So usually when we think about impacts of marine heat waves, which are, periods of unusually warm conditions. So these can occur, they usually occur in summer predominantly, but they can also occur in winter and spring. And so when we talk about historic patterns, we find that most of the severe impacts that we've seen have occurred during the warmer months. And this makes sense because marine organisms are kind of at their maximum. And so this is historically what we've seen. But in this study, what we're seeing now is that these impacts are occurring, some even in winter and some prior to the start of summer. And this is really important because marine organisms function differently throughout the year. So, in spring, we have a lot of marine organisms undergoing reproduction. They have different resources stored in their body. They have different interactions with other organisms and so on. So the impacts can be completely different at different times of the year.
With El Niño developing in the Pacific, what happens if the oceans keep warming like this?
Yeah, so we know that, projections are telling us that marine heat extremes are becoming more intense, but they're also becoming longer and more frequent. And we know in particular ecosystems like coral reefs, seagrass meadows, that the less time that they have between these impact events to recover, the less likely they are to fully recover in the long term. So yeah, essentially, if you have these impacts in quicker succession, they have less time to rebound and rebuild.
Your study focused on the year 2023 to 2024, when the world averaged more than 1.5 degrees Celsius for the first time since industrialization began 3 centuries ago. Do you see that happening again, possibly in 2027?
It's entirely possible. Yeah. In this study, we're talking about an anomaly in the climate system. So the climate system hasn't yet fully stabilized at 1.5 degree, which is a much more longer term target. But in terms of whether Earth could temporarily reach 1.5 again or even more is certainly possible. And that's, although I'm not a climate scientist, that is what the models are showing, is that it is an extreme, but it is certainly possible.
Meanwhile, in the Atlantic, a powerful system of currents carries warm water north. As that water cools and becomes saltier, it sinks deep into the ocean before flowing back south.
Scientists call it the Atlantic Meridional Overturning Circulation, or AMOC. I know, another acronym experts expect us to remember. But to simplify, AMOC acts a little like a giant conveyor belt, is how they describe it, for the climate, moving warm air from the Caribbean and along the eastern coast of North America towards northern Europe and back again.
But that conveyor belt appears to be slowing down. As the planet warms, melting ice and heavier rainfall are adding more fresh water to the North Atlantic. That makes the water less salty and less dense, making it harder to sink and slowing the conveyor belt that helps regulate our climate. Scientists don't all agree on if or when AMOC could collapse.
What happens if the AMOC does collapse?
We will see unprecedented shifts in global climate and weather, and how, daily activities such as fishing, right, will also change, So how the AMOC is slowing down is we're seeing the Gulf Stream shift a bit north, and the Gulf Stream, for context, is this conveyor belt of, again, really, really warm tropical air that we see, water that we see alongside the east coast of the United States, right? And we're starting to see that shift a bit further north. So how is that impacting places like where I live now in Boston, off the coast of Cape Cod, right? We have lobster fishermen and things like that, right? That are seeing differences in how, much they catch every year or where the position of these different animals are, right? So that's one side of things, right? Wildlife will we get confused. You already have sea turtles that are getting really, really confused about where they're supposed to go because of how the water is, right? So how warm the water is in certain places. So that's one element of it, right? The also biodiversity and then also the food part and how that affects human life. But then if we also talk about weather, we're also seeing a shift in how, or we will see a shift in how, different pressure systems up in the atmosphere respond to what the temperature of the water is. So a prime example of that is when we see the AMOC slow down and some of this warmer water is not making it as far north, or because we see global warming melting the glaciers a bit more, the ice caps, and we see that input of fresh water, cold fresh water into where we expect waters to warm up a bit because of the tropical, transfer from the tropics. We see heat events happen, in Europe because we now have a pressure system that is allowing for the jet stream to lock in some of that warmer tropical air over places like Europe. So we could see shifts, in how Europe experiences weather. We could see a shift in how the jet stream brings different rain bands to different parts of the Amazon. We're talking about a completely unprecedented shift in how we experience climate and global weather in different places.
Considering the AMOC isn't something that's talked about often, how do you convince someone that it is important and it's something that we need to care about?
Yeah, and I mean, I think a lot of the climate skeptics and the climate deniers, like a lot of the times, their argument is that we've seen a lot of these trends happen before. So, again, if we talk about just global warming and climate change, like the globe has been on a natural oscillation of CO2 and temperature in the air for the past 1 million years, right? As far back as our records go. Um, and a lot of times that argument is, okay, well, we've had, really warm periods before, interglacial periods before. We've had glacial periods before, really cold periods. And then even in the past, I believe there was an AMOC collapse at one point, right? But this didn't happen at this time scale, This happened on the order of hundreds to thousands of years, right? It didn't happen within the course of 100 to 200 years, because we've accelerated this process so much with our greenhouse gas emissions. So that's one way, and it's just showing them the data. And if that's not enough, then we take it a step further and we connect to how their way of life, happens, right? So say we have a lobster fisherman who happens to be, a climate denier or a climate skeptic, right? And we can literally pinpoint, well, okay, well, how much lobster did you catch this year compared to how much did you catch last year? And then if we also can correlate that with the fact that the temperature of the water is changing, the currents are changing, I imagine we have a much better case of convincing somebody, because now you're seeing how it affects them in their actual daily life. And that's usually the connection point. How do you find and meet somebody where they are in these situations? And that's a prime example of it.
Nkosi, just before our chat, the US experienced some intense weather. You guys had storms and heat waves just before the storms. Do more people believe today that global warming is actually a real threat?
I think so. I've had the opportunity to live in several different places across the US, and most of the time I'm surrounded by folks who do fully believe that climate change is a real thing. Why? Because I'm a climate scientist by default, right? So by default, we are advocates for the planet. And then also just even in the social media response that I see sometimes too, there are many folks who are like, okay, like if I didn't believe change was a real thing before, I certainly believe it now. Um, Yale does some really good work on this too. They have a Center for Climate Change Communication, or just trends where they have seen how the shift in how people experience climate and how that's affected how they feel about climate change and whether it's real or not, and whether or not they're now more concerned or whether they're actually scared for what's going to happen. That's something that they've actually revealed a decent amount of trending work on per se. I think personally though, yes, I have seen folks start to realize that, okay, well, we're seeing a more severe tornado season. We're seeing more hurricanes happen. And even if there aren't more hurricanes, they are more severe because the oceans are hot tubs now, right? Um, I think it's only, again, it takes one of these events to really strike at the core of somebody's, life for them to realize like, oh, like this didn't normally happen before. Maybe I should actually pay attention to this, and stand up in one way or another.
Meanwhile, we've mapped distant galaxies and sent spacecraft, beyond our solar systems. Of course, we've walked on the moon. Yet, here on Earth, we still know so little about our oceans. Scientists estimate we've only explored a tiny fraction of the deep, leaving millions of species and countless discoveries waiting to be found. But maybe not for too much longer. A British company believes the next great era of exploration won't happen in space, but underwater.
So Vanguard is our prototype subsea habitat. It's intended for a crew of 4 for mission durations of 7 days or more. I say prototype because this is just the beginning for deep. This is the beginning of a much larger roadmap of subsea habitats, modular, deeper water, intended for installations in oceans around the world.
Habitat supports researchers and scientists because they're allowed to stay on the bottom and really immerse themselves in that environment. So instead of just dropping in a single dive and seeing what's happening in this really short time frame, you actually get exposed to what's happening in that habitat 24/7. So you really get to know that environment and really get immersed in that environment. You also have the opportunity to do those dives outside of the habitat up to 6-8 hours at a time versus just a single hour on the bottom. So you can really expand the research capabilities on the bottom. Habitat benefits conservation efforts because it allows individuals who are doing things like coral restoration that extended bottom time. And so instead of having to drop down and trying to build out coral nurseries and do coral planting in short time frames, like 30 minutes up to an hour at a time, when you're in saturation, you can go out and really conduct an extensive amount of work for restoration efforts, which we're really excited about integrating with Vanguard.
This is a milestone moment for deep, for ocean science, and for me. For me personally, for deep, it's our prototype subsea habitat. For ocean science, this hasn't been done in 40 years. I think of deep as an enabler for science. What brought us here today on Tennessee Reef is deep's commitment to build the first underwater habitat in 40 years and place it here at Tennessee Reef, working with Florida Keys Marine Sanctuary. Now that we're here, deep's role is a facilitator of science and scientists who want to do work in this ocean realm.
Hey, if I asked you which sea creature is the most impressive in our ocean, would you say the shark, the whale? Yeah, they're great, but think smaller. It's time for Just to Matter, where the little things can mean everything. Today, plankton, tiny drifting organisms that are usually invisible to the naked eye. But without them, life on Earth would look very, very different. And that's our show. But before I leave you, a new documentary is exposing the impacts of illegal octopus fishing in the Mediterranean. The film, which is being showcased globally, follows crews as they locate and remove thousands of destructive traps.
raising awareness to protect the species from being fished to the brink of collapse.
I really think we've given everything just to protect this environment.
The octopus has fascinated scientists for decades because of its remarkable intelligence and behavior. Octopuses are invertebrates, meaning they have no backbone. The studies show they can solve complex problems and even use tools. Their brains evolved very differently from ours, giving scientists a rare opportunity to study intelligence from an entirely different branch of evolution. There are more than 300 known species of octopus. Some, like the tiny octopus wolfie, are smaller than a golf ball. Others, like the giant Pacific octopus, can stretch nearly 5 meters from arm to arm. No matter the size, scientists consider them an important part of maintaining healthy ocean food webs. They help control populations of crabs and shellfish while providing food for seals, dolphins, and sharks. Humans prize them too. Octopus has been part of Mediterranean culture and cuisine for centuries, supporting many coastal communities. But conservation groups warn that illegal fishing and growing demand are placing increasing pressure on some wild populations. In northern Greece alone, more than 30,000 illegal octopus traps have been recovered, but campaigners and authorities estimate hundreds of thousands more may still lie on the seabed. Researchers say these traps not only remove breeding octopuses, but also catch other marine life and leave plastic pollution on the seafloor. The more scientists learn about the octopus, the more extraordinary their story becomes. Protecting this remarkable animal is about protecting one of the ocean's most intelligent inhabitants and the fragile ecosystems that depend on it.
The more scientists learn about the octopus, the more extraordinary their story becomes. Protecting this remarkable animal is about protecting one of the ocean's most intelligent inhabitants and the fragile systems that depend on it.